Hello. In this video, I wanted to cover some interesting facts about random sequences. And I think we're going to start with coin flips. So if you have a coin accessible, you can flip coins to generate random sequences of heads and tails. Or you could go to random.org to generate lots of coin flips all at once. Let me show you. Okay, if you go to random.org and then click on games and go to coin flipper, or you can access it here as well. If you click on coin flipper, you'll be able to generate lots of coin flips all at once. So in the worksheet, I asked you to generate 15 coin flips and then 60. So if you click the number of flips you want and pick the type of coin, any coin that you like. One of the interesting things here, I'm just gonna choose regular penny. And then if you click flip coins beneath it, you'll be able to generate lots of coin flips all at once. So here I have 1, 2, 3, 4, 5, 6, 7, 8 heads out of 15. I can flip it again and again. Or if I want to generate 60 coin flips, and you could do that just as easily. No, this time it's a weird different coin. Maybe it's a little bit harder to distinguish if this euro coin is heads or tails. So I guess that would be heads and that would be tails. And you can count the number of heads and tails. Okay. All right. So what I want you to do is record the number of heads you counted out of 15 coin flips and 60 coin flips. And you need a calculator for this. Count what the percentage of heads you got for each try. And one property about random sequence is what's called law of large numbers. It pretty much tells you that the long run statistics will approach the true probability of the event happening. In this case, with 15 coin flips and 60 coin flips, if it's a fair coin, it should be heads 50% of the time. But most likely you don't get exactly half. Like I chose an odd number here, so 15, so you can't even get exactly half, but you'll get some kind of percentage that's roughly, hopefully close to 50%. But if you do more times, 60%, 60 times, you should get, on average, about half the distance from 50% than you would have with 15 coin flips. So you might have worked, or maybe it didn't work, but on average, that is supposed to happen. Let's see. There's some notes. So more precisely stated version of law of large numbers is that if you have a repeated independent trial, so this is what it is. So each coin flip is independent from one another. If you keep repeating, the number of trials with some event A happening divided by the total number of trials will get closer and closer to the true probability of A here. Another fact about, interesting fact about random sequences is that people are really bad at coming up with random sequences. So there really isn't any pattern to random sequences, but it's still difficult to come up with it. So what I want you to try with this experiment is to now try to imagine and write down a random sequence of 60 heads and tails. So pause the video and write it down, like HHT, HTTT, HH, and so on. So try to come up with 60 heads and tails. Maybe block it up into maybe 10, 10, 10, and then 10, 10, 10, 60 of them. And try to see if you can tell the difference between the random sequence you thought up on your own versus actual random sequence of 60 heads and tails. So pause the video and try it out. And what I want you to do is look at your list and sorry. Look at your list of fake random sequence of H's and T's, and then try to count the longest run of heads or longest run of tails you see in the sequence. So for example, here in the short sequence that I made up, 3T is the longest that I see. In your 60 heads and tails, what is the longest that you see? Maybe 3 or 4? Did anybody write down sequence as long as 5? So it turns out that in a real true random sequence, longer streaks of heads and tails occur a lot more frequently than people expect. So in a 60 flips, you might see a sequence of 5 or 6 for a true sequence, but you rarely see that for people writing down fake random sequence of heads and tails. There's some psychological biases on what people think random sequence should look like. And long streaks looks like a pattern that maybe doesn't belong in a random sequence. Although it might be very likely because it's random, certain proportion should occur. It's not the only thing that people are bad at coming up with. I want you to try to come up with a random number between 5 and 10. Do you have one now? More likely than not, you have chosen the number 7, which is weird, right? Because any number between 5 and 10 should have been equally likely for random pick, but people have a psychological bias, and prime numbers are more perceived to be more random than even numbers or other numbers. So people are drawn more towards 7 than 8 or 6 in this case. It's not just coming up with heads and tails or numbers either. Spatial randomness feels the same way. So if you ask somebody and give them a sheet of paper, maybe 8.5 by 11 sheet of paper, and ask them to draw 20 dots, you might get something that looks more like this compared to maybe a true random 20 dots on the right. So imagine true random being if it's raining outside and you put 8.5 by 11 sheet of paper outside and waited until 20 raindrops landed on it, then you might look more like this compared to when people draw random dots on sheet of paper. They tend to more even them out. And there's no big gaps or clumps in the sheet of paper. But in a true random sequence of dots, you tend to get clusters and large gaps. And these things occur more often than people imagine that there should be. Now, both of these are kind of fake. I just kind of drew them just to point out that there should be some clumps and open spaces. So they're both fake. But if they're not aware of these biases, people tend to draw random dots like this rather than a picture you might see on the right. So these are some fake random biases that people might have that you might find interesting. This isn't or useless trivia either, because you could use this to come up with random sequences that are more pleasing to people. For example, if you're designing like an MP3 player, and if you want to play something randomly in a shuffle function, if you pick true random shuffle, then people might complain that certain songs might come up more frequently than others. So if you want to design like a shuffle function on an MP3 player that's more pleasing to people, maybe you can avoid trying to clump together the same song or same artist in a row. So it seems more random to the human that's listening to the music. Maybe not. Then you might find other applications of this biases that might be useful. Anyways, that's it for this worksheet. I will see you in another worksheet. Second.